Okay, for what we have in working with series and summations, we have for y, we have the summation as n goes from 0 to infinity of c of n times x to the n, and we have the fully expanded layout where we have among the first terms, we have c naught plus c1x, and for the rest of the terms you have a match between the subscript and the superscripted values. And we have also the summations for y prime and y double prime. Now, in your series and summation worksheet, for the first problem, okay, we have y prime plus 6y is equal to 0. And if we were to fill in, we have for y prime, okay, so you have c1 plus 2c2x plus 3c3x squared, and so on. For plus 6 times y, we have 6 times c naught plus c1x plus c2x squared is equal to 0. And if we look at what is present, we have putting our terms in increasing degree order. We have with the constants, we have c1 plus 6c naught and we have is equal to 0. For what we have in correspondence to the first degree expressions in x, we have 2c2x and 6c1x, and I'm just going to be looking at the coefficient portions. Here we have 2c2 plus 6c1 is equal to 0. And if I line up what I have in x squared, we'll have 3c3 plus 6c2 is equal to 0. And if I were to venture out further, you would have 4c4, and that would be in reference to x to the third, and we would have also plus 6c3 x cubed. Again, I'm interested in just the coefficient portions. What I'm going to do here is that I'm going to write everything in terms of c naught. We have for c1 plus 6c naught is equal to 0. We will have that c01 is equal to negative 6 c naught for what I have in terms of c of 2. I will have negative 6 c1 over 2 and writing in terms of c naught. Okay, now I have that c of 1 is equal to negative 6 c naught. And that will be over 2. For what I have to come next, writing c of 3 in terms of c of 2 and in turn in terms of c naught. So I have c of 3 is equal to negative 6 c of 2 over 3. And if I were to follow through, we have like negative 6 times negative 6 times negative 6. And that, in essence, will go to negative 6 to the third c naught. And we have 3 times 2, which would be at 6. If I carry out what I have for c of 4, so I have negative 6 times c of 3 over 4. negative 6 times negative 6 cubed. This will be negative 6 to the 4th c naught. And 4 times 6 is going to be at 24. And just some things you might notice. Ultimately, first term we have negative 6 to the 1st c naught. And 1 becomes 1 factorial. Next in line, I have negative 6 squared c naught, and 2 becomes 2 factorial. And then I have negative 6 to the 3rd c naught all over 3 factorial. Then we have negative 6 to the 4th c naught all over 4 factorial. And we will have in the ensuing pattern, we'll have c of n is equal to negative 6 to the n c naught all over n factorial. For what I have in terms of the general solution in y, I will copy this. So we have representing c of n is the above expression. So we have with c of n, so I have negative 6 to the n c naught all over n factorial. And then I have times x to the n and what I will do here is that I will shift the constant out to the front. So we have c naught times the summation. Now we have negative 6 to the n times x to the n. Now we'll cluster together. Here we have negative 6 times x raised to the n all over n factorial. So we have that y is equal to the constant. We have times the summation as n goes from 0 to infinity. Negative 6 quantity to the n over n factorial. And for what we will have in terms of the functional solution, and I will mention we have e to the x is equal to the summation as n goes from 0 to infinity. And we would have x to the n over n factorial. And if you notice, for what we have in y, we have x projected out to negative 6x. Everything else is the same. So for what we have in terms of the official solution, in terms of functions, in algebraic terms, we come out to y is equal to c naught times e to the negative 6x.